Okay, since your teacher's a nut, yeah, I turned it off, so this is the second part of the exact same lecture. Sorry about that. I hit the wrong key, which, if you know me well enough, you know that it's not a big surprise. Okay, so let's keep going. This one we're going to go particles to mass. What's the mass of 4.83 times 10 to the 26 formula units of strontium chloride? So that's my given. That's my unknown. Okay, still got my conversion factors up here. So I start by writing my given 4.83 times 10 to the 26 formula units of strontium chloride. Okay, how do we know which one to use? Okay, well, formula units, the F in FAM, so I'm going to use particles. I'm going to use Avogadro's number equals 1 mole. How do I know which place to put it? Because I just go down the unit, put formula units down here, so I know in front of formula units goes Avogadro's number. And 1 mole of strontium chloride goes in the numerator. That's how I know. So my formula units cancels. Well, I'm at moles right now. I need to go to mass. I'm not to what I want to go to. So I'm going to use this conversion factor up here. 1 mole is equal to molar mass. So just go down the moles. So I put moles of strontium chloride in the denominator. And then I'm going to put molar mass of strontium chloride in the numerator. I have to figure out what that is. So let's see, strontium times 1, OSR times 1, and then chlorine times 2. Strontium's molar mass is 87.62, and 2 chlorines, 70.906. Use your calculator, use your periodic table. You have not memorized these. I may have, but you have not. Okay, so I'm going to add them together, and let's see what I get. 87.62 plus 70.906 gives me that. That's a big molar mass. 158.526. Okay, so 158.526 grams in 1 mole of strontium chloride. Well, moles cancel. I've got grams. Well, good news, that's what I wanted. So I can stop and do some math. I multiply everything in the numerator and divide by what's in the denominator. Let me see if I can get this whole thing on here so you can watch. No, it looks like maybe not. Okay, 4.83 times 10 to the 26th times 1 times 158.526 gives me that number right there. 7.6568058 times 10 to the 28th. Divided by whatever's in the denominator, which is just Avogadro's number. Okay, so I divide denominator into numerator, and I get, ooh, big number. That's a lot of mass. Okay, how many sig figs can I have in my final answer? 1, 2, 3. So 1, 2, 3. So that 1 does not cause that 7 to round up, so I got to round this thing down. So I round it to 127,000. So my molar mass, I'm going to put it down here, 127,000 grams strontium chloride. All right. Okay, so now we're moving on to something a little bit different. We've got one more conversion that we need to learn. It's molar volume. Volume of a gas changes with temperature and pressure. You should know that. If you put a balloon in the car in the summertime, if you leave it in there long enough, the heat is going to cause the volume to expand. It's going to cause that balloon to expand and possibly even pop because temperature changes and it increases pressure. Because of this, gas volume is measured at standard temperature and pressure. STP just means standard temperature and pressure. Standard temperature is 0 degrees C, which is also 273 Kelvin, and 1 atmosphere pressure. 1 mole of gas at standard temperature and pressure is equal to 22.4 liters. So this is going to be our conversion factor. This is our new conversion factor. If we see liters, or volume, we use 22.4 liters equals 1 mole. So to find the volume of any gas at standard temperature and pressure, we use 1 mole is equal to 22.4 liters. So how do we use that? Well, we use it basically the same. Let's see, molar volume, about 22.4 liters per mole. the equality, this is the equality that we're going to use, 22.4 liters is equal to 1 mole. And remember, you can use that conversion factor however you need it. Just depends on what you're doing. So let's try these here. And let's see. What is the volume at standard temperature and pressure of 0.960 moles of methane gas? That is my given, so I box it. My unknown is volume. I'm going to use 1 mole equals 22.4 liters. That's my conversion factor when I have volume. So I start out by writing my given, 0.960 moles of CH4. Disco down the unit, put moles of CH4 in the denominator. Okay, and I'm going to use this conversion factor. 1 mole, 1 goes in front of the mole, is equal to 22.4 liters of CH4. Moles cancel, and the unit I'm left with is liters, which is great because that's what I wanted here. So for the math, we're just going to do 0.960 times 22.4. Get, let's see, oh, there we go, 21.504. 21.504. Okay, I can only have 3 sig figs in my final answer. Beginning is never. The end, yes, it's significant if there's a dot, and sure enough, there's a dot. So I've got 3 sig figs in this. 1, 2, 3 in my final answer. That 0 won't round that up, so my final answer is going to be 21.5 liters of CH4. Okay, number 2, at standard temperature and pressure, how many moles are there in 67.2 liters of sulfur dioxide gas? There's my given. Box my given and circle the unknown. 67.2 liters of SO2. And I disco down the unit. Put liters of SO2 in the denominator. Well, what number goes in front of liters? Well, let's check the conversion factor. 22.4 goes in front of liters. So I put 22.4 here. And 1 mole in the numerator. Because 1 mole is equal to 22.4 liters. So I'm going to multiply everything in my numerator and divide by what's in my denominator. 67.2 times 1 is 67.2 divided by 22.4. So let's see what that is. 67.2 divided by 22.4 gives me 3. 3 whole moles. Alright, well, how many sig figs can I have in my final answer? 3. There's 3 here, so I need 3 sig figs. Well, I got 1 whole number there, so what is it? Yeah, 3.00 moles of SO2. That's my final answer. Okay, last problem here. What is, oh, we're not doing density. Sorry, changed my mind. We're not doing density. I forgot that one was on there. My fault. So let's go on to the next slide. Avogadro's hypothesis. Equal volumes of gases at the same temperature and pressure. So that means that the temperature has to be the same and pressure has to be the same. Equal volumes contain the same number of particles. It's astounding. So at standard temperature and pressure, 1 mole of any gas is Avogadro's number of particles, which also, oh my gosh, equals 22.4 liters of gas. Okay, all of these things are equivalent. Let's see if we can't use all of these conversion factors. Now this is, you're going to have a multi-step, but it's okay. 1 mole could equal Avogadro's number of particles. Remember, in order for something to be a particle, it has to be part of the FAM. 1 mole also equals, we just found out, we just learned, is 22.4 liters of gas. So let's use these 2 conversion factors to do a couple of 2-step problems. How many molecules are contained in 44 liters of nitrogen gas? Well, 44 liters is my given. Molecules is my unknown. I write my given, 44 liters of nitrogen gas, which is N2. I disco down my unit, put liters of N2 in the denominator. Let's go back to these conversion factors. Where's liters? It's right there. What number's in front of liters? 22.4. What number goes on top? 1 mole. Okay, liters cancels. Well, now I've got moles, but I need to go to molecules. So I'm going to go over here and use this conversion factor because molecules is part of the fam. Oh, not equals, times. Just go down my unit. So I'm going to put moles of N2 in the denominator and put 1 in front of it because there's a 1 in front of the moles. Then I'm going to use Avogadro's number because molecules is part of the fam. So 6.02 times 10 to the 23rd molecules of N2. There we go. Moles cancel, and look, I've got molecules. That's what I wanted. So I stop and do math. See, I don't think I can get it on here, but I'll show it to you. 44 times 1 times Avogadro's number. That number right there, 2.6488 times 10 to the 25th, divided by, what's in the denominator? Just 22.4. So let's see what that is. Divided by 22.4 gives me, how many sig figs can I have my answer? 2. 1, 2. The 8 will round that up to a 2. So my final answer, I'm going to put it right here, 1.2 times 10 to the 24th molecules. There I go. There's my final answer. Okay. All right. Last one. Calculate the volume of 125 grams of argon gas. Oh my gosh, grams is not up here. But you know what? We have another conversion factor. 1 mole equals molar mass in grams. You had to know this was coming. Seriously, you had to know. Okay, so let's add grams in here. So that is my given, and volume's my unknown. So let's see how we work this one. Start out by the same way, 125 grams of argon. Dis go down the unit. Well, grams is in the numerator, grams goes down here. Go back up here. What's in front of grams? Molar mass. What's the molar mass of argon? Find your periodic table. Molar mass of argon, 39.948. Alright. What is the molar mass equal to? It's equal to 1 mole. So I put 1 mole of argon in the numerator. Cancel my grams. I've got moles here. So I dis go down my unit. I didn't want moles, I want volume. So dis go down. I put moles argon here. Well, do I have a conversion factor that gets me from moles to volume? Well, I sure do. 1 mole is 22.4 liters. So 1 mole, 22.4 liters of argon gas. Cancel my units. Okay, I'm left with liters, which is volume, which is what I want. So I'm going to multiply everything in the numerator. Let's see, 125 times 1 times 22.4. And I'm going to divide that by what's in the denominator, 39.948. And I get, ooh, big number. I can only have 3 sig figs in my final answer. 1, 2, 3. So the 9 is going to round the 0 up. So my final answer is going to be 70.1 liters of argon gas. Okay, and that's today's notes. Good luck.